Here we have the FLC 3015AJ fibre laser machine. Amada initially started looking at the development of fibre technology almost 10 years ago. So we've known this technology for a long time, but our first offering was a 4 kilowatt high spec, high speed machine. Due to customer requirements and the changes in some industries, we looked at offering a 2 kilowatt machine, still with full linear drive capability. And the reason we chose linear drives for the fibre machines is to take full advantage of the fibre technology. It fits in very well with the high speed cutting and the high applications and so on. But really the machine here, it's a 2 kilowatt fibre laser. So it's primarily aimed at the thinner range of materials, but it's part of what we call the process range expansion concept, PRE. So it allows customers who would normally only cut the standard materials such as aluminium, stainless steel, mild steel. It allows them to expand into areas such as titanium, copper, brass and so on. Primarily, the machine really is aimed at people cutting maybe up to 10mm thick mild steel. It's capable of 16mm, but really primarily it's more of a thin sheet machine. But we've sold some to general subcontractors who may go from 1mm aluminium to 10mm mild steel or 16mm mild steel. The oscillator on this machine, as with all fibre lasers we make, has been developed in-house. We thought it's better to develop our own in-house because we can dictate the development cycle, how it fits with the machine and so on. One Amada philosophy is to have complete control of the development, so we develop the oscillator ourselves and we build that in-house. The linear drive technology on here, again, we've used for many years. The first machine we launched was in 2004 with full linear drive. So this machine takes advantage of the speed and the high acceleration rates of the linear driven technology. So in order to give us very stable cutting and production, we have a system that monitors the piercing. And if there's any delay in the piercing, the machine will keep piercing until it knows it's through the material. And similarly, when it's cutting on profiles, if it encounters some bad part of the material, it will automatically slow the machine down so it can then remake the cut and carry on again. So the customer has full confidence that they can do full production without any particular cutting problems. The machine has a nozzle changer as well, so to allow customers to swap and change between materials very quickly with minimal setup, we have an 8-station nozzle changer. So this allows the customer to put on one material, press start and run. Change material, press start. If it needs a different nozzle, the machine will automatically change this. But also here we have the MPF automation system as well, which is a single pallet automation system on here. So the customer can load one pallet of material and leave to run unmanned overnight. So with the features I mentioned just now, it gives very stable production, 24 hours a day, for instance. Many years ago in Japan, they made a study of standalone machines compared to automated machines. And they found that the setup time in particular for standalone machines was very, very high. So one of the development cycles behind the automation is to completely reduce the setup time. So for instance, if a customer has a large batch to run, rather than someone loading sheets on manually, which is all downtime, the machine's not producing anything, so therefore it's not making any money, using automation systems enables them to run seamlessly 24 hours a day, and they can just take the parts away when they're finished without interrupting the cycle of the machine. Load a new pallet, carry on the cycle again. So the setup time is drastically reduced from maybe 50 or 60% setup time down to maybe 10%, just for the sheet loading. This was really the development and the idea behind the automation systems that we offer today. If we go from fibre technology to CO2 technology, there's still a very big market for CO2 machines. So the next machine we'll look at, the LCG laser, we've developed specifically to have some characteristics of fibre laser, but also the other advantages of CO2 machines as well.